So now we're into the problems that have the parentheses. The left-hand side is still going to be easy to reduce. Similarly, the right-hand side is going to be easy to reduce. It's just the way I write my answer that's going to be the issue. So I'm going to solve with the square root property just like I did for the non-parentheses problems. Square root the left side plus or minus square root the right side. Problems that have squares like this should get two solutions. The left-hand side, the square rooting cancels out the square. Technically, it leaves me with the x plus 2 in a parentheses. That square actually turns into an exponent of 1. The left-hand side really just wipes out the entire need for a parentheses, and it's just going to make the radicand without the parentheses appear. And then on the right-hand side, square root of 81 is just 9. Because the right-hand side in this parentheses problem, because the right-hand side simplifies, it doesn't have an I and it doesn't have a square root, my best answer doesn't have a plus or minus sign. This is the one instance when I'm solving with square roots that I don't have a plus or minus sign in my answer, and I even forgot to bring the plus or minus sign down there. That was a mistake. My answer shouldn't have a plus or minus sign, but I need two answers. When a problem has a setup like this, I need two answers. I'm going to get those two answers here in a second. I'm going to minus 2 from both sides, and on the right-hand side, I'm going to put the minus 2 before the plus or minus sign. This is a bad answer. It's correct, but it's not so great. So I'm going to make up the separate problems that are implied by this plus or minus sign. The problems implied by the plus or minus sign are x equals negative 2 plus 9 and x equals negative 2 minus 9. These can be combined. Negative 2 plus 9 have opposite signs, so to combine those I subtract. Negative 2 minus 9 have the same signs, so to combine those I add. I'm going to say for problem 10, the best answer doesn't have a plus or minus sign. It's going to be x equal to 7 and minus 11. Just because it's a new kind of problem, I can show you that I can check these. The original problem was x plus 2 squared equals to 81. If I wanted to check x equal to 7, I'd go, is 7 plus 2 squared equal to 81? I could check that in my head, but it's easier on my calculator. And when I do 7 plus 2 squared, I get 81 equal to 81. So that checks. If I wanted to check the x equal to negative 11, usually when I'm putting negatives in, they need to go in a parentheses. But this is a case where I really don't need a parentheses. It wouldn't be wrong to have that negative 11 in a parentheses, but it's not necessary because the x is kind of a naked x. The x doesn't have a coefficient, it doesn't have an exponent. You don't really need it in a parentheses. So let me do the left-hand side. Negative 11 plus 2 squared, and that checks as well. So this is the big deal. Now we're in the world of the parentheses problems. In the parentheses problems, after you simplify the right side, you look at the right side. If the right side has an I or a square root, my best answer will have a plus or minus sign. If the right side doesn't have an I and doesn't have a square root, my best answer doesn't have a plus or minus sign. And the problem I just did, when I simplified the right-hand side, it didn't have a square root, it didn't have an I, my best answer didn't have a plus or minus sign. I'll move on to number 12. I'm exploiting my calculator heavily to reduce because I don't care to reduce by hand these radicals. So square root plus or minus square root. The left-hand side, the square rooting cancels out the square, makes it so I don't need the parentheses. And the right-hand side, the plus or minus sign shouldn't go away, but the square root of 121 is just 11. Because the right-hand side doesn't have an I, it doesn't have a square root, my best answer doesn't have a plus or minus sign. So I need to solve this. I'm going to minus 7 from both sides, and get 3x equals minus 7 plus or minus 11. And then I'm going to divide both sides by 3. And it's going to make my life a lot easier if when I divide by 3 on the right-hand side, I make a big denominator and have that big fraction with a 3 in that denominator. So this gives me x is negative 7 plus or minus 11 over 3. Because that 11 doesn't have a square root or an I need to get a better answer by making up the two problems that are implied by that plus or minus. The two problems that are implied is x equals negative 7 plus 11 over 3 and x equals negative 7 minus 11 over 3. This first one, the numerator, there's one positive and one negative, so I subtract the numbers and get a 4. The denominator stays 3. The second one, the numbers in the numerator are both negative, so I'll add the numbers and keep them negative and get negative 18 over 3. The second one reduces to negative 6. So my best answer for problem 12 won't have a plus or minus sign. It's the numbers 4/3 and negative 6. The order that you write those in isn't important. You could write the negative 6 first. It wouldn't matter. The next few problems are going to be parentheses problems again, but the right side, when it simplifies, it will either have an I or a square root or both. And when that happens, my best answer will have that plus or minus sign. So for 14, I'm going to square root plus or minus square root. Square root of 48, I'm calculator reducing, is 4 square root of 3. And on the left-hand side, the square rooting that side just leaves me with x minus 8. Because the right side has a square root, the best answer is going to have a plus or minus sign. So let me solve this for x by adding 8 to both sides. And I'm going to get x equals 8 plus or minus 4 square root of 3. I'm going to say this is the best answer. An okay answer would be x equals 8 plus 4 square root of 3, comma, 8 minus 4 square root of 3. But I can't say this is 12 square root of 3. If I try to go 8 plus 4 square root of 3 on my calculator, those aren't like terms. They can't be added. That doesn't add to 12 square root of 3. Similarly, 8 minus 4 square root of 3 doesn't subtract to be 4 square root of 3. These can't be combined. A wrong answer would be to say this is 12 square root of 3 and 4 square root of 3, because you're adding terms or subtracting terms that can't be subtracted. In order to add or subtract when you have radicals, both pieces need to have the same radical. That 8 would also have to have a square root of 3 to be able to add these or subtract those. So the reason I say the best answer has a plus or minus sign, because this okay answer is this implied in that, and it's more efficient to write it like that. And if you do to the okay answer, you might simplify it when you can't, because it's illegal. You can't subtract a constant that doesn't have a square root with a constant that has a square root. I'm not going to check those because it's going to take too much time. For 16, but they would check. All of these, solving with square rooting plus or minus square rooting doesn't introduce extraneous solutions. So for 16, square root plus or minus square root. The left-hand side, I get 5x plus 9. The right-hand side, square root of 84 is 2 square root of 21. The right-hand side has a square root. If the parentheses problems you're solving and the right side has an I, a square root, or both an I and a square root, my best answer has a plus or minus sign. I shouldn't make up separate problems, one with the plus, one with the minus. So now I'm just going to solve this by minusing 9 from both sides. This will give me 5x equals minus 9 plus or minus 2 square root of 21. And then I'm going to make the big fraction on the right-hand side. Divide by 5, divide by 5. That's the nicer way to write the answer. I can make small fractions on the right-hand side. I might show that a little bit like in another problem just to show you the alternate way that these answers could be written. I guess I'll show it now. I could have done this. Instead of writing a big fraction on the right-hand side, I could have written two small fractions, and these are equal to each other. In fact, if I enter this bottom one, I can't do the plus or minus sign, but if I did negative 9 over 5, I can't do plus or minus, but plus fraction 2 rad 21 over 5, which is another form of the answer. If I hit equal on my calculator, it will turn it into this form. It has a plus sign, not quite the plus or minus, but these are equal to each other, and these are both correct. The bottom answer, it's maybe a safer answer when it comes to things that can reduce, but I'm not quite ready to talk about that yet. All right, we're getting deep into this. 2 more problems and then we'll probably break for another part of the video. 18 and 17 are ugly. Let me do 17 just because I would never do something like this on a test. So x plus 1/3 squared equals to 49. Solving with square roots. Square root plus or minus square root. The left-hand side becomes x plus 1/3. The right-hand side plus or minus square root of 49 is 7. Since the right-hand side doesn't have an I, it doesn't have the square root, my best answer shouldn't have the plus or minus sign. And I get the ugly fraction here. So I'm going to minus 1/3 from both sides and get x equals minus 1/3 plus or minus 7. I'm going to make up the 2 problems that are implied here because my answer shouldn't have a plus or minus sign. So negative 1/3 plus 7 and negative 1/3 minus 7. I'm content with you doing these on your calculator. So you can do fraction negative 1 over 3 plus 7 and get x equal to 20 over 3. And fraction negative 1/3 minus 7 and get x equal to negative 22 over 3. Those are my 2 answers without the plus or minus sign. If I wanted to do those by hand, I'd need to make the 7s a fraction by writing them over 1. I'd need to make the 7s have a denominator of 3 by writing the fraction form of the 7 and multiplying it by 3 over 3. This would give me x equals negative 1/3 plus 21/3. And x equals negative 1/3 minus 21/3, which would be x equals negative 1 plus 21 over 3. That's going to be positive 20/3. And x equal negative 1 minus 21 over 3. That's negative 22/3. So my answer for this shouldn't have a plus or minus sign. It's going to be 20 over 3. And minus 22 over 3. This would never be on a test, but good to see. 19 and 20 are going to be easier, even though they have a fraction. I don't have to do so much work. I can leave a plus or minus in my answer. So for 20, and you can do 19, square root plus or minus square root. The left-hand side I get y minus 1/5. On the right-hand side, I have the plus or minus sign, and the square root of 19 is not a reducible square root because 19 is a prime number. So the right-hand side just stays the square root of 19. And because the right-hand side has a square root, my best answer should have a plus or minus sign. So I'm just going to add 1/5 to both sides. I'm not going to worry about making simplifying that right-hand side. I'm just going to leave the plus or minus sign because the best answer has that plus or minus sign. I'll say this is a best answer. There is a way to add these and get common denominators. My calculator probably does that. If I do fraction 1/5 plus square root of 19, my calculator knows how to make a common denominator. But I'm not going to worry about that. This wouldn't be on the test, and so this is a good enough place to stop. You should be able to do 19. I think I'm going to pause the video and do a part 3. There's probably going to be 5 parts to this section for the videos. Ugh.